All right, we're back again. This is part 2 now of Learning Guide 14. We are on topic 1. Okay, so now we're going to use our algebra skills to prove these identities. So remember the rules that we just learned. So the first rule is we're going to change everything to S's and C's. So this becomes an S times 1 over C times C over S. Now you remember, you have your formula sheet, so please use it. Now I can cross off those C's and those S's, and I have 1. So check mark, I have the 1 equaling 1. So number 2, we know this is 1 over C. And this is S over C times 1 over S. Cancel, cancel. And now I have 1 over C. Check mark. Okay, so it doesn't matter which side you can attack. You can go the left side or right side. You're just trying to prove that they are identical. So this one here, we have cot, which is C over S, divided by 1 over S. So now we have our complex fractions going on, so let's multiply by S. All right, so now we are left with C, check mark. See, there it is. I didn't have to do anything to the right side. All right, now on the bottom one here, I can rainbow this in. So we have secant plus secant cos. Now I'm going to change it to S's and C's. So we have 1 over C plus 1 over C times C, cancel. So I have 1 over C plus 1. And look over here, we have the same thing. So check mark. Now we have an S plus a C over an S. All right, so now we have here a 1 plus a C over an S. So there's not much I can do here on this side. This is pretty much it. But over here, I can make a common denominator S, so criss and cross, so it's S plus C. And there it is. I made it. All right, so now here we have 1 plus S over C and 1 over C over S. All right, so complex here. So we see there's a S and a C, so that means S and C, S and C. Don't forget everything now. All right, so we can cancel out to get rid of that complex. So I'm left with this times that, so that's SC plus S squared, SC plus C squared. All right, so now I'm going to factor. So an S can come out of this top one here. So C plus S. And on the bottom one, I see a C common. So S plus C. And these can cancel out even though they're backwards because it's a plus sign. So all that work is to get an S over a C. Okay, let's try this right side. So we have 1 minus S over C, and we have C over S minus 1. Okay, complex. So I have, again, an SC. So that C takes that out. That s takes that out. So now I am left with sc minus s squared and c squared minus sc. So let's factor the top. So we have an s, so it's c minus s, and on the bottom we have a c, and we have a c minus s, and then cancel and cancel, so I have an s and a c, and they equal. Okay, looking at this one now, the Pythagorean identities. So we know that s squared and c squared equal 1, and we know that this equals 1 minus c squared, and this equals 1 minus s squared. We talked about that. Now, these identities, you're going to use the Pythagorean identities. So we have this guy right here, which is this guy here, which becomes s squared. Now this side we have a c squared times an s squared over a c squared. So we have s squared, check mark. All right, number 8, let's rainbow this out. So let's go secant squared. Now when I rainbow the middle ones, because you see these guys are plus 1, minus 1, they cancel out. Now I can change things to s's and c's. 1 over c squared. Don't forget about that too, because it's a squared there. And now I have common denominator, c squared. So criss and cross, so 1 minus c squared. And I just mentioned these Pythagoreans are going to show up a lot. So here's one right here. So let's change that guy to s squared over c squared. Now, you'll develop into skills now when you get involved more and more with this. This you'll write as a tan squared of theta. Okay? For right now, I just want you concentrating on just leaving like this, just till you work out your mechanics. And then we'll get into writing them out. Okay, so over here I have 1 over c squared over s squared. So that's times it by s squared times by s squared. And so I have s squared over c squared. And there's the match. All right, and the non-permissibles are, remember back in grade 11 we talked about non-permissibles. Those are things on the bottom that we do not want to be 0. So in this first situation, we have cosecant x, which becomes this guy, and then there's the bottom, and so it cannot equal that. Then I look on the unit circle where sine is 0, and I know it's sine is 0 there and there, so the non-permissibles are there. So this one is 1 over cos and sine plus 1. Well, I have two denominators here I have to look at. This guy, so cos x cannot equal 0, and I know that's at pi over 2 and 3 pi over 2. In this bottom one, if I take that out and make it equal 0, I have sine x equals negative 1. And that is sine x of negative 1 is 3 pi over 2. And let's try this one. You guys can have a go, and you can pause it and then check the answer with mine. And here are the answers. So you should have sine x cannot equal 1, and that's at this guy, and cos x cannot equal 0.